Hello everyone, welcome to your third Python tutorial on GNU plus Linux. In this video we'll be first discussing conditions in Python. This is how we check the state of the system, and it's a very core concept to programming as a whole. Alright, so the first condition is an equality test. 12 equals 12. Notice how I'm using two equal signs here instead of one. That's going to come back true, because if I try to say 12 single equals 12, it's going to say syntax error, because 12 is a numeric literal, meaning it is just a literal numeric value to the Python interpreter, and you can't have a variable name with that starts with a number, so it's going to tell you that you can't assign to a literal. Because the single equals means assignment, as in like x equals 3. It's an assignment. I suppose I should space that out, so x equals 3 is the way that I would usually do it. As assignment, if I do x double equals 3, it's going to say true because I've already set x equal to 3. Next is not equals, so I could do x not equal. You do that with bang equals, not equal 3. It's going to say false because x is 3. I could also do x bang equals 12, true. Alright, I can do x is greater than or equal to 3, and that's going to come back true. I could say 2, and that's going to say true. I could say 4, and it's going to say false because it is less than 4. Okay. I can also do x is less than 10, or x is less than negative 2. And that's going to come back false because it's greater than negative 2. Next is in. So I can say x in 1, 2, 3. And it's going to come back true because x is in that list. If I come back and I say y equals that, I could say x in y, and that'll come back true. If I set y equal to this without the 3, then x in y comes back false because it's not in there anymore, because x is 3. Okay. And finally, you can take the opposite of anything by saying not x in y. Or, if you wanted to make it more readable, you could do x not in y, and that also comes back true. Okay, one thing you want to watch out for is the is operator. A lot of people are tempted to use this in place of double equals, but you should not do that unless you know exactly what you're doing. So, double equals is an equality test, and is an identity test. So, let's say I set a equal to 1, and b equal to 1, and then I say a is b. That's going to come back true. But this is not for the reason that you think it is. It's not because a is equal to b, because if I set a equal to 6,000 and b equal to 6,000, they're still the same, right? A is b. False. What? Well, that's because they're not in the same position in memory as each other. But if I do an equality test, it's going to come back true because they are really both 6,000. So when you're testing equality for numeric values, you need to use double equals, not is. Is only for instances where you actually know what you're doing. Okay. Now, what can we do with these conditions? It's nice to know that these are true and false, but what can we do with them? Well, if you've ever looked at programming in the past, you're certainly familiar with the if statement. This is the most basic logical test. You say if, and then give it a test, and we'll say if a equals b, print yay, and this is going to print yay because a is equal to b. We can also test, let's test if a is an even number. So let's say if 0 is equal to a mod 2. Print even. And it's an even number because 6,000 is an even number. And the reason we test that is because we know that when we take the modulus, that's the remainder. So if we divide it by 2 and it equals, the remainder is 0, then we know that it's an even number. We can also do if not a modulus 2, print even. And it's still going to do it too, because if I say not 1 or not 0, whenever you put not in front of something, if it's 0, then it comes back true. If it's 1, if it's actually anything besides 0, it comes back. So if I say not -70, then that's still going to come back false, because basically if you put not in front of a number value, if it's 0, it's going to come back true. If it's not 0, it's going to come back false, which means that you can now do shorthand instead of checking if something is equal to 0. You can just say not. But saying if 0 is equal to something is more explicit and is preferable in code, because people will know what you're going for. You know that you're actually caring if it equals 0. Alright, one other thing we can do. Let's say if 0 equals a modulus 2, print even, else print odd. Of course, it's still going to print even, but let's say a plus equals 1. This will add 1 to a, so now if we check it, a is 6001. Now I can go back and do this same thing again. And now it will print odd, because it is an odd number. So I give it a condition right here. This is the condition. If that's true, then do this. Otherwise, else, do this. Okay, now if we need to check for multiple conditions, then let's see what things are a multiple of. So let's say let's make a equal to 15. Okay, now we can say if 0 equals a mod 3, print multiple of 3. Elif, I'm going to pronounce it elif, that stands for else if 0 equals a mod 2, print even, else print odd. Actually, we'll say other, since a multiple of 3 is also an odd number, or can be. Let's see. So it's going to say multiple of 3 because 15 is a multiple of 3. If I set a equal to 14, then it will say even, because 14 is an even number. And you can see where this is going. And you can put as many elifs as you want, and the else at the end is optional always. But you must have an if before an elif, of course. Okay. Now, here's another thing that we can do with conditions. We can also create a loop. Let's say while, and then a condition, and it will loop infinitely as long as that condition is true. And if the condition ever becomes false, then it exits the loop. There's also a keyword called break that you can use to get out of the loop if you need to by force. So let's do something to find the biggest multiple that something is a multiple of, up to 100. So let's say max equals 100, and we'll say while, let's see, while max is greater than or equal to 0, then we'll say we can leave that. While max is greater than or equal to 0, then we can say if 0 is equal to a mod max, then we print multiple of max. Okay. And then regardless, we'll say max minus equals 1. Okay? So this is going to go backwards down the whole thing and say what A is a multiple of. Okay. Oops, we got a zero division error because we didn't check, because 0 is not allowed. Right. But you see, it's a multiple of 14, it's a multiple of 7, it's a multiple of 2, it's a multiple of 1, of course, because everything is a multiple of 1. And we can't check 0 because of reasons. Kudos if you saw that coming, because I wasn't thinking about it. Okay, so, well, you got it. Okay. And actually what we could have done is if we just wanted to find the biggest one, then we could have put break right here, and then that would have stopped it, and it would have printed multiple of 14, and then it would have stopped. Of course, that's always going to happen first. It's, of course, a multiple of 14. Okay, but that's what a while loop does, and you see where they can kind of get dangerous if you don't pay close attention to the condition. For instance, I put greater than or equal to 0, but of course, if it is equal to 0, then you're going to get a zero division error because you can't divide anything by a 0. One last thing for conditions is variable assignment. So I can say A equals 12 if 3 divided by 3 is 1, else 11. Of course, 3 divided by 3 equals 1 is always going to be true, so A is going to equal 12. But you could put any condition here you wanted, and then you could put an else and then something here. And basically, this is how you can do a conditional variable assignment. Instead of having to say, if 3 over 3 equals 1, colon, new line, and then indent, and put A equals 12, and then a new line, and then else, colon, and then A equals 11. You can shorten it all to just this nice one-liner, which is one of the really neat things about Python, is how many different one-liners that you can do in it. Okay. Now let's go and make our first program that uses conditions. So I've got a file here called password.py. I'm going to open it up in Emacs. Okay, let's put our shebang at the top. USR, bin, env, pytut03. Alright. So what we're going to do here is we're going to make some sort of very basic user authentication system. Okay. So we're going to have a dictionary of users. Users equals. Okay. And we're going to have Bob. And his password is going to be chicken, because Bob likes chicken. And we're going to have Steve, whose password is spaghetti. Okay. Alright. And we could add as many more as we wanted, but let's not. Okay. So now we need to get what the person's name is. First of all, we're going to create a system. We're going to say tries equals 0, because they haven't tried yet. And we're going to say while tries is less than 3. And we're going to say tries minus equals 1. Plus equals 1. Right. Because now they've tried again. Okay. So while tries plus equals 1. While tries is less than 3. We're going to give them 3 tries to get in. We're going to say user equals input username colon space. Okay, and we're getting this as a string on purpose. Now we need to get the password. But if you remember, let's jump back over to the terminal. If you remember, if I do x equals input and then something, notice everything I type is still there in front of me, and if I push enter, it stays there. Even though I get the value, it's right there. We don't want to do that with a password, so here's what we want to do. Over in Emacs, we want to from get pass import get pass. Remember, I said there are a lot of built-in things, modules at our disposal that we can use. So get pass is one of them. So we're going to say password equals get pass. And by default, get pass does something kind of like this, but instead of saying username, it says password. We can change that if we want to, but let's leave it as password. Okay, so now we have both of these. And now we'll say if if we'll say if password equals user, we're getting the userith element of the user's dictionary. So basically this is checking. So if I type Bob here and Bob is user, it's going to say if the value for Bob, that equals the password, then we let them in. So then we could say allow. And by the way, these are comments in Python that I haven't shown you about yet. So if you need to type something just to say what your code is doing, then you can do this here. Actually, it would be better if I did it here. Allow. Okay. So then we allow them. So we'll say print granted, else, and we'll say deny. We'll say print denied. Now let's jump up here for a moment, and we'll say break, since now we don't give them another try because they're in. And okay, so then that's it. So let's go ahead and save it. Jump back to the terminal. Let's exit the interpreter. We'll do pytut03 password.py. Username Bob, password chicken, granted, and the program exits. Now if I did username equals Billy and I typed anything for the password, it's going to say key error. Well, okay, so we need to make a check. Alright, so let's jump back over to Emacs, and this is how we make sure that nothing breaks. If there's an error, so we'll say try, and we'll bump all this stuff up, bump all that up, and then we'll say except key error, because that's the error we got. Then we'll print no such user. Okay. So that's an introduction to error handling there. So if you're getting errors because of what you're doing, then you fix it with that. So we'll save that. We'll jump back over to the terminal. Try it again. Billy, blah, no such user. Okay, fine. Steve is a user. And let's type in chicken, but that's Bob's password, so denied. But if we type, I don't know, linguine, because we know that Steve likes pasta, so we're trying to guess his password, it's still going to say denied, and this time it exited, because we only get 3 tries. Alright, so that's a basic login system. You can certainly make a much better one than that, but you're now to the point where you're able to make pretty basic actual programs now. Being able to have these conditions and loops is central to just about all programming. So we have variables, we have conditions, we have loops, and we also have error checking. So you're now getting to the point where you're becoming very proficient and able to create scripts in Python. Python is a good scripting language, but we want to get into programming. So in the next video, we'll talk about how to make real programs in Python with little bits of code that we can reuse over and over and do programming the right way. At this point, we're just scripting. We're going to become programmers. I'll see you in the next one. Happy hacking.